All right, so let's everybody join me back on the first page. Any problem with the vocabulary? Our center, our radius, our diameter. Let's fill in. This is our chord. Our center. And then, of course, our circumference. Represents that distance around the circle. The two versions of the formula for finding the circumference, whether you think of it as 2 pi r or pi d, it doesn't matter because your diameter is twice your radius. So both of those, and they do that. That does need to be memorized. So if you're like, I can't remember it, think about, oh wait, I measured the distance around my round object and I divided it by the distance across. Remember when we did that activity? So think back to that activity to help you remember the fact that the distance, and you can write it this way, the distance around divided by your distance across was how we calculated pi. So if you look at this fits our activity that we did if you just multiply each side by d. So that was why we spent the time doing that. All right, when we talk about arc measures, whether we're talking about secants, tangents, minor, major arcs, central angles, or semicircles, you need to know what part of that circle we're talking about. Any questions on those? About arc measure, the diameter, and make sure you know the difference between when we're talking about a minor arc and a major arc. When we're talking about arc length, remember, if you prefer to think about it in terms of a ratio, when you're talking about part to whole, you're talking about the length of the arc compared to the circumference of the entire circle. So which fraction of the circle do you have? So when we're talking about each of these, I know that 2 pi r is my equation for the circle. I substitute my radius value. Rule of thumb, we're going to use the pi button on the calculator and round to the nearest hundredth. If they ask it for you in terms of pi, then you just don't press the pi button. They gave me my circumference, so I plugged in what I knew and solved for what I needed. If I'm looking for the length of AB, it's this fraction of the whole. 2 pi r is the whole, so this fraction of the whole, and that's what I get. If you want to see it written as a proportion, just ask and I'll be happy to do that for you. Any questions on 1 through 6 on this page? I had a couple people ask. Adne, did you have questions on these? Number 5. If I need to find the circumference, I'm told that this arc measure is 12 centimeters, and I know that 12 centimeters is this fraction of my whole. So when you see the equation written out, my original equation is 12 is equal to this fraction of the whole circle around. So this is just a piece of the entire distance around the circle. So then all I'm going to do here is multiply by the reciprocal. So if it's 85 over 360 times my c, if I multiply each side by this reciprocal, this 360 and this 85 cancel out. So I get 12 times 360 divided by 85. Now I don't have to go any further and find my radius because here they just wanted the circumference. So I know the distance around my circle is going to be 50.82 centimeters. Now for this one, they're asking for the radius. So instead of having the circumference here, I've got 2 pi r. So same thing. This is the length of my sector. Here it is. My distance from A around the circle to B is equal to this fraction, 132 out of 360, of my whole. And instead of writing it as a C for the circumference, I have to write it as 2 pi r because I'm going to have to figure out what this r is equal to. My reciprocal takes care of this coefficient. My 360s cancel out. My 132s cancel out. Times 14.2. And that's how I get that radius. Are you okay with that? Okay. Any other questions on page 1? All right, let's talk about page 2. Same exact conversations, but now we're talking about areas. So on the quiz, if you're not sure what the shaded area is, make sure you ask, and we'll be happy to clarify for you. Here's just the whole area of the circle. 2 problems where I'm just finding the area, pi r squared. That's another formula you need to have memorized. Pi times r times r. And if you think about it, remember when we made those circles into parallelograms? And that parallelogram, remember, had r as my height and pi times r as my length. So my area is pi times r times r. That has to be memorized. Your inches squared, centimeters squared, millimeters squared, because what you're doing is figuring out how many little squares fit inside that round shape. So make sure you get your units right. Any questions on finding the area or the fraction of the area? What piece of the pie do we have? Olivia, what you got? So 6, when I add together my fraction, this is 90 degrees. This is 40 degrees, and it's a central angle. So I know my arc here is 90 because my angle's 90. My arc here is 40, so my angle's 40. So when I talk about which fraction of the circle, when I add that together, it makes 130.
I found my 90 area. Maybe I solved the wrong thing, but.
So what ends up happening is you can do this in 2 stages or 1. I combined it into 1 because this fraction is 40 degrees out of 360. This is 90, so I added my 40 and 90 together. So I only had to do this math once. If you did it separately, if you found a fourth of the circle and then you found, what's that, a ninth of the circle and added them together, you should have still gotten the same answer. I find it easier to add my degrees of my shaded part together, so I'm only doing this multiplication once. You're allowed to do that.
And you put the pi, like the pi 25 over x or?
So if it's 25 times pi, that's in my numerator.
Okay.
And then multiplying fractions is no problem, top times top, bottom times bottom. And when I do that math, when I enter those things in on my calculator, so what I'm going to do, like for this one, I'm going to go ahead and do 130 times pi times 25, and then that whole value is divided by 360.
Okay.
So that's how I'll enter those calculations. I like to use my calculator to kind of keep track of my work. Like I fill my window with what I'm doing, and I'll hit enter because I want to make sure that number 1, I'm not pressing the wrong buttons. Number 2, I'm not messing up with the order of operations. And number 3, I can repeat my steps and double check myself. Any other questions on this one? Rachel, did you get your question answered?
Oh, yeah.
Okay. All right, so here, Ethan got you guys a Smartie because it asks you for distance in feet. So if I have this inches, if I divided that by 12, that would give me it in feet, right? So if I did 36 times pi, that's where I get my and then times 2, because it goes around twice, right? That's my 226.19. If I divide it by 12 inches, it should give me 18.85 feet. Does that sound right? And then if I had 36 times pi times 10 revolutions, and then I divided that by 12, that's going to give me 94.25 feet. Ethan, do we match? Yeah? It's a crooked line. Okay, so over here, pi d is going to give me pi times 28 for the circumference of my pi times 28, and then times 2. So this 175 divided by 12 is going to give me 14.66 feet. 28 pi times 10 divided by 12. That, oh, this one comes out even. Isn't that weird? Oh, that's not right. I messed up on my buttons. It's not even close to being. So 73.30 feet. Does that look right? Yeah. Okay.
So we just have to find the circumference
I found the circumference,
and then divide it.
and then I had to double it because I found the circumference, and then I had 2 revolutions, so I doubled it, and then divided by 12. And then for 10 revolutions, I found the circumference, I multiplied by 10, and then divided by 12. And then my mountain bike, instead of my diameter being 36, it was 28, so I did all that same math. Finding the area, I found the area of the big circle minus the circle inside. Area of the square minus the area of the circle inside. You okay with that? Next part, I played with the tangents. Here's my internal tangents, and I know that they're internally tangent because it crosses an imaginary line between the 2 centers of the circle. These circles are internally tangent. These circles are externally tangent with an internal tangent line. A box around my internally tangent circles. Radii are perpendicular to every point of tangency. So we're going to be doing lots of Pythagoras. 2 tangents coming from a circle to an external point are always going to be congruent. Don't forget when you take the square root, plus or minus. And then I went ahead and I plugged in both the positive and the negative 4, and I still get 2 positive answers. So both of those answers were legit. My first triangle is acute. My second triangle is obtuse. My Pythagorean converse. Number 9 was my avalanche problem. If I have a diameter that's a perpendicular, that means it's a bisector, so x is going to be 8. It's just a matter of looking at it. If I had to justify, I would say because TV is a diameter, an angle, and they intersect at a perpendicular angle, that means that these are going to be the same because it's bisected. On the back, central angle is worth half of its intercepted arc. The arc is double the central angle. And 2 angles that come from the same intercepted arc are going to have the same measure. Opposite angles in an inscribed quadrilateral are supplementary. And this was a repeat from your notes. And this was repeat from your notes. Did you notice that? We'll have to fix that for next year. Sorry. This was the one I messed up on. I found the measure of 51 degrees. But it's asking me the measure of X, Y, Z. So that's from X all the way around to Z. So if this is 51, this is 102. So the rest of the circle is going to be 360 minus 102. So 258 degrees. And the paragraph proofs, are you finding yourself, oh, go ahead.
For the,
Olivia first, then you.
oh, yeah.
Sorry.
Number 5, a few questions, especially the other side, but on number 5 on this page, can't you do 5 basically 10x minus 20 equals, equals 8x plus 20, 32, something like that?
Yeah, you can say double this is equal to that. Or you can say this is equal to half of that. You should have still gotten the same value for X. Did you?
I didn't do it because I was so lost. I didn't know.
Yeah, because over here, Olivia, I have the other one. I could double this, or I could half that. Whatever I got to do to make them equal.
Number 6 on the other side, and number 7 is kind of confusing.
Yeah, so the radius is going to be perpendicular, and that gives me a right triangle that I can put through Pythagoras. So my hypotenuse is 20, and my one leg is 5, and I don't know what my other leg is. So I'm going to go ahead and use Pythagoras to find it. 7, this point external is going to guarantee that these two tangents are congruent. So I'm going to set them equal to each other and solve. I end up with a quadratic. So this step here, I can take the square root of each side. And I have to remember that's plus or minus.
Okay.
Nazifa?
Number 8 on that side, is it the measure of the diameter or just half an inch?
So you know what, we ended up talking about this one, and the reason why it had to be 18 was the whole diameter is because if it was 36, it would be bigger than the hypotenuse. So if you're confused about whether a value represents the radius or the diameter, ask. Because this one, it has to represent the diameter, right? Yeah.
So when we're taking the quiz, do we like round to like the 100 place?
Always the 100. Okay?
For the test, should we leave it in a radical, simplest radical form, or put it in the decimal?
I'm pretty sure it says 100th and what to round. If it doesn't, ask me and I'll clarify.
I know we went over this already, but I don't think I really understand it on what page is it? The one where it was like the tire rotations or revolutions. I just don't.
So what ends up happening is this is a tire, right? And that tire has a certain diameter. So here's my tire. And I know that this tire has a diameter of 36 inches, right? So it wants to know when it rolls, how long would 2 revolutions be? So basically what I'm just asking for is twice the circumference.
Okay.
So my circumference is equal to pi times my diameter. So my circumference is 36 times pi, which means I'm going to then also double that for my 2 revolutions. The next one, they want 10 revolutions. So a revolution is just it going around in a circle.
Gotcha. All right.
Okay?
Thank you.
Sure. Olivia?
For example, number 6, the one with the with like the at the point of tendency raised perpendicular. Do you want us to leave it in the simplest radical or put it in decimal?
So wait and see what the quiz says. For the most part, I think we stuck with decimals on this one. Okay? All right, so when you finish your quiz, there's a note sheet over here that I want you to take it to try to read these new relationships and figure them out and practice problems on the back. My goal is to be able to get to that our last portion of the class after lunch.